Hello everybody. Today we are going to discuss about the statistics. Type of data. Data can may be either qualitative data or quantitative data. Qualitative data can be nominal or ordinal. Quantitative data can be discrete or continuous. Now the measure of the central tendency. The sum of the value, mean is sum of the values of observation divided by the number of observation. Median is the central value of data series when data are lined up in order to magnitude. Mode the most frequently occurring values in set of observation. It is not always representative of true. So mode is the most frequently occurring value in the set of observation and it is not always representative of true central values. Shapes of distribution. Normal distribution. Normal distribution is the symmetrical and the bell shaped with one side is mirror image of the other. If distribution is normal, the mean and the standard deviation are preferably as the summary of the data. The mean, mode, and median are equal. Now the skewed distribution. The distribution that is asymmetric. A distribution is skewed, that means mean, a median, and the interquartile range are preferable as a summary of the data. The skewed is named according to the direction in which tail points. The skewed distribution with the long tail among the lower value is skewed to the left and the negatively skewed. The skew distribution with the longer tail among the higher value is skewed to the right and positively skewed. In general, if the curve is skewed, the mean is always towards the longer tail. The mode is always on the top of the curve, and the median is somewhere between the two. When the data is negatively skewed, that means mode is greater than the median is greater than the mean. If data is positively skewed, that means mean is greater than the median and median is greater than the mode. The logarithmic conversation may transfer the skewed distribution to the normal distribution. Positive skew has a tail to the right and the mean greater than the median. Negative skew has a tail to the left and the median greater than the mean. The skewed distribution, the median is better representation of the central tendency than its mean. So first diagram is representative of the negatively skewed data. Then the second diagram is the normal, that is no skew. Mean, median, and mode is in the center. Then the third diagram is representative of the positively skewed data, that is in the positive direction. So measure of the variability. Measures of the variability tell you that how spread out or how much variability is present in the set of numbers. Measures of the variability should be reported along the measure of the central uh, tendency because it provides very different but complementary or important information. Measures of variability includes the range, the variance, and the standard deviation. The range is the difference between the largest and the smallest value. Variance is the average of squared differences between the value and mean. It measures how far the set number is spread out. Um, The small variance indicate that the data points are to be very close to the mean and hence to the each other. High variance indicate that the data points are very spread out from mean and from the each other. The variance of 0 indicates that all values are identical. So we'll repeat once again the variance. Variance is the average of squared difference between the value and the mean. It measures how far is the set of number is spread. A small variance indicate that the data points tend to be very close to the mean and hence to each other. High variance indicate that the data points are very spread out from mean and from the each other. Variance of 0 indicates that the all values are identical. Standard deviation, it is a square of the root of variance. The standard deviation tells you that how far the number tend to vary from the mean. Standard deviation should only be used when the data has normal distribution. It is important to distinguish between the standard deviation of the population and standard deviation of the sample. They have different notation and they are computed differently. The percentile and centile. The value below which certain percentage of values falls. The value at 50th percentile means half of the data above and half of the data below that value. Interquartile range usually describes the data which falls between 25th and 75th percent. Lead time, the interval between the identification of a condition by screening and development of the symptom. Lag time is the interval between the intervention being assessed as clinically useful and the intervention actually entering everyday practice. Now about the Z-score. The standard deviation has specific relation to the normal distribution. The normal distribution is the distribution that many common and the important variants are followed. A Z-score converts the raw score into number of standard deviation that score lies from the mean of the distribution. So Z-score is calculated as follow, where X means sample mean, mu is population mean, and upon standard deviation. Now application. It is applications are calculating confidence interval, calculating sample size, comparing variation between the variable measured on separate scale, calculating Z-test of difference between the mean of two groups and proportion of the two groups, and to find relative importance of variable in the regression analysis. Now percentile. Percentile is a point on the scale where certain population of the population lies at or below. For example, scored at 75th percentile means that 75% of population have scored at or below that value. Percentile are the type of standard score, which means that raw score is converted to the score that has known meaning. In case of percentile, the known range is 0% to 100% and the midpoint is 50%. Percentile can be used to determine their relation to the population. Now the standard error of mean. It is also known as standard error. It is a standard deviation of the sampling distribution of the mean. It is the measure of how precisely the sample mean approximate the population mean. It measures the scatter of data around the mean. It is calculated by dividing standard deviation by square root of the sample size. The standard error of the mean must be equal to the standard deviation. Standard error is not used to calculate chi-square test as it compares the population and it is not related to the standard deviation. Standard deviation and standard error may only be used in normally distributed population. Standard error of mean is affected by the two factors. That is standard deviation greater the standard deviation greater the standard error of mean. And sample size, that is smaller the sample size greater the standard error of mean. Now next is confidence interval. It is a range of value in which we are fairly confident the true population values lies. Therefore, confidence interval gives the estimate range of the values which is likely to include unknown population parameter. So confidence interval is usually reported as 95% of confidence interval. So confidence interval is mean plus or minus z into standard error. So confidence interval is equal to the mean of the sample plus minus z score multiplied by standard error. 95% confidence interval is equal to z score of 2. 99% of the confidence interval is equal to z score of 2.5 and 99.7% of confidence interval, that means z score of 3. Confidence interval is affected by the variation in population and sample size. Smaller the sample size, larger the confidence interval. Null hypothesis underlies all statistical tests. Null hypothesis says that findings are the result of chance and the random factor. If you want to show that drug works, the null hypothesis will be the drug does not work. For example, example of the null hypothesis, a group of 20 patients who have similar systolic blood pressure at the beginning of study is divided into two groups of 10 patients each. One group is given daily dose of experimental drug meant to lower blood pressure, and the other group is given daily dose of placebo. So blood pressure in all 20 patients is measured 2 weeks later. So null hypothesis assume that there are no standard differences in the blood pressure between the two groups at time 2. If the time if time 2, the patient in the experimental group shows the systolic blood pressure similar to those in the placebo group, null hypothesis is not rejected. If the patient in the experimental group have significantly lower and higher blood pressure than those in the placebo group, null hypothesis is rejected. Intention to treat analysis. In RCT, the outcome of the two allocation group should be compared irrespective of whether patient actually received or compared allocated treatment or had missing data or poor compliance. This avoids introducing bias into assessment of treatment. Now the interim analysis that are carried out before the end of clinical trial in order to assess whether the accumulating data are beginning to demonstrate beneficial effect of one treatment over the other with sufficient certainty. This can avoid further patient being randomized into inferior treatment. Now the bias. First bias is sampling bias. Volunteer subject in a study may not be representative of entire population being studied. As a result may not be generalized to entire population. Then selection bias occurs when there is systematic difference in the way group are chosen. One method of decreasing this bias is randomization. Then the third bias is recall bias. Patients who experience different outcome have different likelihood of recalling an exposure than do patients who do not have the adverse outcome, independent of true exposure of the outcome. Then expectancy bias occurs when physician knows which patient are in treatment versus placebo group, causing physician to draw conclusion supporting the expected outcome. One method of decreasing this bias is the double-blind design. Then late loop bias. Result from the information being gathered too late to draw conclusion about disease or exposure of interest from entire study population. Then measurement bias describe how information gathered affects the information collected. For example, Hawthorne effect describes how patients act differently when being watched. Then proficiency bias. This issues when comparing effect of different treatment administered at multiple sites. Physician at one site may have more skill providing better treatment. Then publication bias. It is where researcher publish only favorable results. It is tendency to publish research with positive outcome more frequently than research with the negative outcome. Negative outcome refers to the finding nothing of statistical significance or casual consequences, not to finding that something affects us negatively. Then media bias. Tendency of the media to publish medical stories with positive outcome than the negative. Reducing bias in the clinical treatment trial. Blind studies, placebo, cross-control studies, and randomized studies are used to reduce the bias. Blind studies. The expectation of the subject can influence the effectiveness of the treatment. Blind studies attempt to reduce this influence. Then single blind study. The subject doesn't know what treatment he or she is receiving. Double blind studies. Neither subject nor clinician evaluator knows what treatment subject is receiving. Then the placebo. In the blind drug study, subject may receive the placebo rather than the active group. People receiving placebo are the control group. People receiving active group are the experimental group. A number of subjects in the research studies respond to treatment with the placebo alone. Then the crossover study. In crossover study, subjects are randomly assigned to one of the two. Subject in the group 1 will receive the drug and subject in the group 2 receives the placebo. Later in the crossover study, the group switch and those in the group 1 receives placebo. Those in the group 2 receive the drug. Then the next is randomization. In order to ensure the proportion of the healthier and sicker patient is the same in the treatment or the control group, subjects are randomly assigned to the group. Number of subjects in each group doesn't have to be equal. Now the reliability. Reliability refers to the reproducibility and dependency of the result. Interrelated reliability. It is the measure of whether the result of test is similar when the test is administered by the different rater or examiner. Test related reliability. It is the measure of whether the result of test are similar when person is tested second or third time. Now the validity. It is a measure of appropriateness of the test. That is whether the test assess that was designed to assess. Sensitivity and specificity are the component of the validity. To be useful, testing instrument must be bias-free, reliable, and valid. Coverage is the proportion of the children in population who have been screened over a period of time. Acceptable screening test should give a yield of at least 1 in 10,000 positive diagnoses of treatable condition. Then quantifying risk. Quantifying risk includes absolute risk, relative risk, attributable risk, odds ratio are the measure to quantify the risk in population study. Odds ratio is calculated for case control study and meta-analysis. Absolute, relative, attributable risk are calculated for cohort study. Now the risk, it is the probability that event will happen. As one boy is born for every 2 births, risk of giving birth to the boy is half or 0.5. If 1 in every 100 patients suffers a side effect from treatment, the risk is 1 by 100 or 0.01. Absolute risk. It is the probability that patient will have medical event. It is the ratio of the number of the people who have medical event divided by all the people who could have the event because of their medical condition. So absolute risk is expressed as the percentage. Absolute risk is equal to the incident rate. For example, the research study have found that among 10,000 people aged 75 years or more who a drug like ibuprofen for osteoarthritic pain, 15 of them will die from the stomach bleed. The absolute risk of dying from the stomach bleed is 15 out of 10,000 or 0.15% of people taking ibuprofen. Then absolute risk reduction. It is the difference in the absolute risk. It is a way of measuring size of differences between the two trends. For example, if incidence rate of lung cancer among people in New York and the New Trenton in 2013 is 20 by 1000 and 15 by 1000. The absolute risk is 2% in New York and 1.5% in New Trenton. The absolute risk reduction is 2% minus 1.5, that is 0.5. Then the relative risk. It compares the incidence rate of the disorder among individual to risk factor with incidence rate of same disorder among individual not exposed to risk factor. So relative risk is the incidence rate of the exposed group divided by the incidence rate of the unexposed group. That is, relative risk is the experimental event rate upon control event rate. For example, incidence rate of the lung cancer among smoker in New Jersey is 20 by 1000, while incidence of lung cancer among non-smoker is 2 by 100. Therefore, the fold increase in the risk of lung cancer for smoker versus non-smoker in New Jersey population is 10. So relative risk of that is 0.02 divided by 0.002. So relative risk of 10 means that in this city, if the individual smokes, his or her risk of getting lung cancer is 10 times than that of the non-smoker. Now the relative risk reduction. It is a proportion of the percentage by which intervention reduces the event rate. For example, this clinical trial of the drug to prevent migraine, 2 of 100 people taking drug experience migraine compared to 4 of 100 patients taking placebo. So the relative risk reduction ratio is 0.5, that is 50%. Now the next is attributable risk. Attributable risk is useful for determining what would happen in the study population if risk factor were removed. Attributable risk is the incidence rate of the unexposed group subtracted from the incidence rate of exposed group. So the attributable risk is unexposed group minus exposed group. For example, incidence rate of the lung cancer among smoker in New Jersey is 20 by 1000, while incidence rate of lung cancer among non-smoker is 2 by 1000. Therefore, risk of lung cancer attributable to the smoking is 0.018. Now the odds. They are calculated by dividing the times an event happened by number of times it does not happen. For every two births, one boy is born and the one boy is not born. So odds of giving birth to the boy is 1/1. That is 50%. If 1 in the 100 suffers the side effect from the drug, the odds are 1/99, while the risk is 1/100. Odds ratio is the measure of association between exposure and the outcome. An odds ratio is the relative measure of the effect, which allows the comparison of intervention group of the study relative to the comparison or placebo. Since the incidence data are not available in case control study, the odds ratio can be used as estimate of relative risk in such a studies. They are calculated by dividing odds of having been exposed to the risk factor by odds in the control group. So odds ratio is equal to 1. That means the likelihood of exposure to the risk factor is identical to the case in the control. If odds ratio is more than 1, that means likelihood of exposure to the risk factor is greater for cases than the control. Odds ratio less than 1 means likelihood of exposure to the risk factor is lower for cases than the control. So odds ratio should always be presented with their confidence interval. If confidence interval includes 1, the relationship between the risk exposure and the disease occurrence is not statistically significant. If confidence interval does not include 1, the relationship between risk exposure and the disease occurrence is statistically significant. The width of interval estimates the precision of odds ratio. So small confidence interval indicates the higher precision of the odds ratio, and large confidence interval indicates the lower precision of the odds ratio. Now the next is number needed to treat. Number needed to treat is the number of person who need to take the treatment for one person to benefit from the treatment. It is a reciprocal of attributable risk ratio. So it is the more meaningful than the relative risk ratio for assessing the efficacy of the treatment. Relative risk ratio is the constant regardless of the risk, while the NNT is likely to be higher in the lower risk group. So NNT is 1 divided by attributable risk ratio. Now the next is number needed to harm. Number needed to harm is the number who needed to be exposed to risk factor for one person to be harmed who would otherwise not to be harmed. So NNH is 1 divided by attributable risk. Now the screening test. Screening tests are often used to identify individuals who are at risk of the disease. Individuals who are positive on screening test may be investigated further to determine whether they are actually have disease. Some of those who are screened positive will not have disease, and some patients who are screened negative will have disease. Sensitivity denotes the probability of the positive test result when the disease is present. It is calculated as percentage of the individual with the disease who are correctly categorized as having the disease. And test would be considered negative in general if it is positive for most individual having the disease. Specificity denotes the probability of the negative test result when the disease is absent. It is calculated as percentage of individual without the disease who are correctly categorized as not having the disease. The test would be considered specific in general if it is positive for only small fraction of those without the disease. Now about positive predictive value. It denotes the probability of the disease being present when the test is positive and is calculated as percentage of individuals with positive test result who actually have the disease. Negative predictive value denotes the probability of the disease being absent when the test is negative and is calculated as percentage of individuals with negative test result who are actually free from the disease. So this is the formula of sensitivity, that is A upon A plus C. Specificity, that means indicates the absence of disease, and that is indicated by the that is negative test, that is D upon B plus D, where A is the true positive, B is the false positive, and C is the false negative, and D is the true negative. So the positive predictive value is A upon A plus B, and the negative predictive value is a D upon C plus D. So we can summarize the information about diagnostic test using measure called as likelihood ratio that combines the information about the sensitivity and specificity. It tells us how much positive and negative test result changes the likelihood that subject would have disease. So the likelihood ratio of the positive test result is sensitivity upon 1 minus specificity. The likelihood of the negative test result is 1 minus sensitivity upon specificity. So if likelihood ratio more than 1 indicates that the test is associated with the presence of the disease, and if the likelihood ratio is less than 0.1, that means test result is associated with the absence of disease. Now the receiver operating characteristic curve. Receiver operating characteristic curve, it is the plot of sensitivity versus 1 minus specificity or plot of true positive rate versus false positive rate for different positive cutoff of the diagnostic test. It shows relationship between the sensitivity and specificity. Any increase in sensitivity is accompanied by the decrease in specificity. So ROC gives idea of accuracy of the test. Area under curve gives the measure of test of accuracy. ROC curve is calculated by complex mathematical model but can be easily obtained by various computer programs. So this is the example of the ROC curve which we are comparing between the true positive rate and false positive rate. Now the next is Kaplan mirror estimate curve. It is a type of estimator used for the survival analysis. So it shows the proportion of the patient in whom understudy has occurred over time. Construction and interpretation of the curve. The Kaplan-Meier curve has a fraction of the patient survive on the y-axis and time on the x-axis. The curve begins from the 100% survival, that is upper left corner, and moves downward as as the time progresses. It can also take into account the patient withdraw from the study and the loss to follow and alive at the end of study. This data is called as sensor data. It can show at any time to the event analysis. Users examine recovery rate, find effectiveness of treatment, estimate probability of the death, calculate survival rate, and gives the prognosis. Compare two or more treatment options to give more suitable plan. Limitation, it does not take other covariant into account while estimating survival. They are non-prognostic static cohazard model, which is parametric and can give survival adjusted for the covariant. Now the next is forest plot. Forest plot is the graphical manner of presenting means and confidence interval of study so that they can be easily reviewed and compared. It is convenient and easily understandable manner of presenting study results in systematic review and meta-analysis. It is used mainly to present result of individual study in systematic review, meta-analysis, as well as meta-analysis and systematic review itself. It shows the effect size of all studies and result of meta-analysis. Now part of the forest plot. So left side, it enumerates the number of various studies which have been included in meta-analysis in chronological order. Right side, it represents the measure of effect of studies included. So square represents the individual study effect and the size of the block varies to reflect the weight of particular study has in overall analysis. Then the black line represents square plus black line represents the confidence interval of the study. Smaller the block which have less weight generally have larger confidence interval than the larger. Then diamond shape represents the overall and summary effect. The outer edges of the diamond represents the confidence interval. The square in the diagram is the measure of effect of study and the horizontal line represents the 95% confidence interval of the study. The size of each square is proportional to the weight of the study. The diamond in the plot represents the overall effect of meta-analysis. And vertical line represents the line of no effect and null hypothesis. Correlation exists if there is linear relationship between the two continuous variables. The strength of relationship is denoted by Pearson correlation coefficient, which is denoted by R. Correlation coefficient indicates how closely the point lie to the line. Correlation coefficient gives the means of linear association between the two continuous measures. The two variable moves in the same line, same direction, that means R is positive. If two variable moves in opposite direction, that means R is negative. The R ranges from -1 to the plus. It implies no linear association. Zero implies no linear association between variable, although there may be non-linear one. +1 and -1 represents the perfect positive and negative correlation. Different values have the different implication for strength and the relationship. The correlation coefficient may be strong but statistically non-significant because of sample size. The statistical significance of the correlation coefficient is based on the associated p-value. For normal distribution, the Pearson correlation coefficient is used, and non-normal distribution, the Spearman correlation coefficient is used. Now the regression. Regression analysis is used to find how one set of the data relates to the other. Linear regression is used to describe relationship between the two quantitative variables, how one value varies depending on the another value. It is mainly used when there is one major dependable variable and one or more independent variable. In simple regression, there is one quantitative dependent variable and one independent variable. In multiple regression, there is one quantitative dependent variable and two or more independent variables. So the regression line is given by the equation y plus mx plus c. So y is dependent variable that equation tries to predict. X is independent variable that is used to predict the y. C is regression constant and m is regression coefficient. It can be used to predict what value the y may take for given values of x. Correlation and the regression are easily confused. Correlation means the strength of association between the variable, and regression quantifies the association and should only be used if one of the variable is thought to precede or cause the other. Logistic regression analysis can be used to compare proportion, making adjustment for the other factor, yielding adjusted odds ratio. Now the types of significant test. Statistical tests are used to analyze the data from the medical studies. The result of statistical test indicates whether to reject or not to reject null hypothesis. So statistical test can be parametric and non-parametric. Parametric tests are the population parameter and are usually used to identify the presence of statistically significant difference between the group when data is normally distributed. The sample size is large. Commonly used parametric statistical tests include t-test, sometimes called as student t-test and student pair t-test, analysis of variance, that is ANOVA test, and Pearson coefficient of the linear correlation. Student t-test, it is a statistics that checks if two mean are reliably different from each other. It is used for comparing single small sample with population or to compare the difference in mean between the two small samples. Use student t-test when you have one nominal variable and one measurement variable and you want to compare mean value of measured variables. The nominal variable must have two values like female and male or treated or untreated. It is inappropriate if more than two means are compared. The larger t-value, larger the difference between the two. Smaller the p-value, stronger the evidence that null hypothesis is untrue. T-value, that is variance between the group, that is variance within the group. So t-test may be paired or unpaired. Now unpaired t-test, it is used to compare the average of two groups of numerical data provided that values are appropriately normally distributed and samples are not small. Paired t-tests compare the means of two small paired observation of numerical data, either on same individual or on the match individual. If two sample t-tests are invalid, that means Mann-Whitney U-test. Analysis of variance. This is the set of technique used to compare means of more than two samples. They can also allow the independent variable which may affect the outcome. Chi-square test. The chi-square test given by the Carl Person is a non-parametric test. It follows the chi-square distribution, commonly used to compare categorical variable when sample size is more than 30. Chi-square distribution is the right skewed and its distribution opened up on the degree of the freedom. It is particularly useful for analysis of categorical data. Now the steps are stating the null hypothesis and alternative hypothesis, preparing the contingency table, then calculate the chi-square testing, calculate the degree of freedom, compare the calculated chi-square value to the table value for given degree of freedom. Decision rule accepting or rejecting null hypothesis. So chi-square value does not give the strength of association. If sample size is small or expected frequency in any cell of the contiguous table is less than 5, chi-square may not be applicable. Fisher exact test is useful in this scenario. The clinical application of the chi-square test, it is used for testing goodness of the fit, testing independence of attributes, then testing homogeneity, and testing the trend. Commonly used non-parametric tests are chi-square, Wilcoxon sign rank test, Wilcoxon rank sum test, Mann-Whitney U-test, and Kruskal-Wallis test. Now the type of error. Type 1 error is rejecting the null hypothesis when it is really true. That there is difference between the data set. That is assuming that there is difference between the data set when in fact there is not. So chance of the type 1 error is given by the p-value. If p-value is 0.05, the chance of type 1 error is 5 in 100. That is 1 in 2. The probability of the type 1 error is designed by the Greek letter alpha, which is called as type 1 error rate or significance level. Then type 2 error is failing to reject null hypothesis when it is really false. That is the chance of type 2 error cannot be directly estimated from the p-value. So the probability of the type 2 error is designed by the Greek letter beta and is called as type 2 error. The type 1 error is generally considered worse than the type 2 error. If null hypothesis is not rejected, there is a chance of type 1 error. If null hypothesis is rejected, then there is no chance of type 2 error. Now the statistical power. In statistics, power is capacity to determine the difference if there is one. The power is directly related to the type 2 error. Power is 1 minus type 2 error. Power indicates that the probability of not making type 2 error. So the power is probability of correctly rejecting false null hypothesis. So the power of hypothesis test is affected by the three factors. That is sample size, significance level, and effect size. Thank you guys.